Hello everybody. Today we're going to do some work on raycasting. In the previous episode we triggered this sound object by walking into a radius, but what we want to do is actually click on it. And in order to click on it we have to know where we're pointed, so we're going to do a raycast. This is something you should really know how to do. Don't worry about memorizing the exact words, just understand it and you can keep looking up the words every single time you need it. So we're going to create a new object class called a hotspot. This is a new mono behavior. I'm going to drop it on the capsule. And we'll turn off the old way. So the way that the hotspot will work is it will allow us to click on an object. Anything that is a hotspot can be clicked on. So for that, we're going to want to go ahead and start with some events. Public Unity event on highlight, on dehighlight, on select. There you are. That's all we need. Now, how do we call those? How do we trigger those? Well, we need to do a raycast and determine whether or not the raycast has hit us. So we need to have a ray. What do we want? We want a raycast from the main camera, the thing we're looking at. So camera.main, yep. Camera.main, there it is. And then raycast, screen point to ray or viewpoint to ray. We don't know how many pixels wide the thing is, and that's the screen part, so we're going to go ahead and use the viewport instead. It runs from 0 to 1, so an easy trick, you can just say vector 3.1 divided by 2. And there you go. You have your ray. We also need a raycast hit. This is where we'll store the information about what we hit. Okay? So this line here is the one that is going to confuse you if this is your first time doing this. The thing we use is called physics.raycast. But if you notice, come on you, bool. It does not return a hit info. It returns, did I hit anything, period. And this is something which takes a little bit of getting used to. So let's pass it the ray and look at all of these options. There are 16 different options for what we can pass this particular function. Ray, max distance, hit info. See that letter out, that prefix out? Out means that it will fill the variable up with while it's in that function. So basically it returns a bool, but you can pass it this hit info to fill up the hit info as well. There are lots of other things we can pass it, max distances and layer masks and all sorts of other stuff. It's all quite nice. We don't need to do any of that though. This returns a bool. Did we hit anything? So surround it in an if statement. So if we hit something, then what did we hit? Well, we want to see if it's us. If hitinfo.transform equals transform, that means it hit us. So if it didn't hit us, return. Otherwise, log it. Let's take a look, shall we? Hit me. See? And you can see how it counts up on the right there. 500 hits, 700 hits. That's because every single frame it does the raycast. Raycasts are expensive. You don't want to do 15,000s of them, every single frame. But, they're not too expensive. You can throw in a couple dozen, no problem. So we have this raycast, and it is going to detect whether or not we got hit. So let's go ahead and just put in a bool if we got hit. Now, why are we doing this? We want to be able to trigger the on highlight and on dehighlight. So public bool, protected bool, highlighted. That way we'll know whether or not we need to trigger on highlight or on dehighlight. We don't want to trigger on dehighlight every single time it misses us, and we don't want to trigger on highlight every time it hits us. And I'll show you why in a second. So here we say on highlight equals true. And what we actually want to do is, sorry, not on highlight, hit us equals true. So we've just refactored this code a little bit. And previously we said if you didn't hit us, just go away, we don't care. Now we're saying if you did hit us, that's all we care about. And down here we'll say if hit us does not equal highlighted, highlighted equals hit us. If highlighted on highlight dot invoke, else on dehighlight dot invoke. So what we've just done is we've created the highlight tool. And now, if we are highlighted, then we invoke ourselves. We invoke the highlight tool, and if we're not, we don't. What happens if we click? We want to be able to click, right? Well, there are lots of ways to detect a click, but the easiest way is if input dot get mouse button down 0, then we are clicked. So if we get clicked and we're highlighted, on select dot invoke. So right now there's no max range involved here. We can click on it from anywhere on the planet as long as we're very precise. That's probably not what we want, so let's go ahead and put in a public float max range equals 5 meters. And then down here in the hit info we will say if hit info dot distance is less than or equal to max range. That's the only time we do true here. And of course we can compress this down. There's no reason it has to be 2 ifs. Perfect. So we could actually limit the raycast to the length that we have specified. We're not going to do that for a variety of reasons. We'll get into it later. So right now we have these events that can be triggered properly. So what do you say we actually put them to use? Well, first off, the obvious event on select, we want to play our music. There we go. What about on highlight and on dehighlight? You really need to make sure that the player understands what they're pointed at, and to do that you want to have a highlight function. Later on we might bake in some highlighting and dehighlighting utilities, but for now we don't really have any baked in, and they'll have to be, a one-off situation. So what we should do is maybe put in something that lets us see that we've highlighted. So here's just a simple particle system. Oh. There. We'll just leave it like this for now, and we'll turn it off. So what we'll do down here in the capsule is we will simply turn it on and off. So set active is the thing that turns it on and off, and there we go. Let's see if this works. Yep. When we get within 5 meters, it starts to glow. And when we click, we get the sound. So there we go. You have learned how to raycast. So now I'm going to teach you about refactoring. Refactoring is an absolutely critical part of your game development process. If you're not refactoring, then there's probably something wrong with your code that you're not addressing. I've never found anyone who does things perfectly on the first try. The more experience you have, the less errors you're likely to make. But let me show you why we need to refactor. If I have this capsule here, it's the only interactive object I have. So obviously, I'll want to make more interactive objects. So we'll call this a boombox. And we can save it as a prefab, but I'm not going to because I might have to start over. And we can just start duplicating it, right? Come on. The great thing about Unity events is these duplicates all keep the correct Unity event focus. So each one will trigger itself. Now, what's wrong with this? Aside from them all having the same music and it not making much sense, there are a couple of problems with this. The biggest problem is that every single one of these is running the code we just created. This update call gets called for each of them every frame. Why is that bad? Because we're doing a raycast for each one of them. What if we have 50 of these? Then even if they're not on screen, there's going to be a raycast for every single one of the 50. And we could get around that by like turning it on with a trigger, when it's within 50 meters or something. There's a lot of problems with doing it like this and trying to get around that is a huge pain in the butt. We're not going to do the raycast here. We're going to do the raycast once, and then we're just going to pick whatever hotspot we happen to hit. So we're going to go ahead and create a raycast script. We're going to call it player interface. Why? We can name it whatever we want, and let's drop it on the player. Come on, player. No. There's our player interface. So when you refactor code, you're normally not just cleaning things up or fixing bugs. You're normally changing the fundamental way in which your code flows. Now, in this case, what we're going to do is we're going to take a piece of decentralized code and centralize it. This is not always the right choice. Sometimes you might have to do it the other way around. As you go through your game development life, you keep making more and more prototypes, you'll eventually get a strong feeling for whether or not it's good to be decentralized or centralized. But even then, you'll sometimes need to switch it up later if your design changes a little bit. So there's no problem with changing whether something is centralized or decentralized, as long as you don't get mired down in it. So what we actually need to do is here in update, just gone. And over here in player interface, we're going to say public hotspot highlighted. And then we're going to paste this in down here. Now there's a lot of stuff we have to fix here. For example, bool hit us is now going to be a hotspot hit. The ray is the same, the hit cast is the same. And then here, rather than doing this, we say hotspot hit equals hit info dot game object, but I guess there's no game object. We have to just say transform dot get component hotspot. So what'll happen here? Well, we just said, okay, whatever we've hit, go into the transform and look for anything that is a hotspot. So as long as your hotspot is on the same object as whatever you hit, you'll be able to find it. Now this does mean that you can't do wacky stuff with your colliders, but that's fine. And then we say if hotspot hit does not equal null, then what we want to do is the same thing we did down here. If hotspot hit dot range dot max range if hit info dot distance is less than hotspot then hit hotspot hit equals see, I tried to copy it too fast. I got ahead of myself and got screwed up. Hotspot hit already has what we need in it. So what we're actually doing here is we're checking to see if we need to set it back to null. That is to say, back to not hitting anything. So this is actually going to be a greater than, and we can say hotspot hit equals null. So what we've just done there is basically the same thing we were doing before. We say if we hit something, check to see if it's a hotspot, and check to see if it's in range. But we had to change a lot of the variables. We had to be like, okay, well, we're not using a bool anymore, and this part's backwards. Refactoring is like that. Don't get too caught up in how you did it before. Make sure you think through how you're going to do it next. And if you start to get confused, take a second. Think about it. Maybe even draw it or doodle on a piece of paper to figure it out. And of course, don't be afraid to look stuff up on the internet. This is something that's very hard for you to do if you're using canned scripts. So if you're running around, copying a script into your game without understanding how it's going to work, you're going to run into a situation where you need to do this, and you can't because you don't understand the script that you're trying to retrofit. But as before, we can compress these if statements. All right, so now we have a hotspot hit, and we have the hotspot that we've highlighted. So what we're going to do is we're going to say if hotspot hit doesn't equal the highlighted, then the highlighted equals hotspot hit. I wonder why it's not properly highlighting. That's fine. And then we say if it's not equal to null, then we want it to run the invoke. Oh, sorry. There it is. Now, I actually don't remember whether or not you can do this. We'll find out in a moment. The problem is they might be protected in some way where I'm not allowed to directly access them. And the same thing is here. Highlighted does not equal null, then in the highlighted object, we want to call this function. Same basic idea as we did last time. All we did is we are now calling it from this class instead of from the hotspot. The hotspot is now a passive class. All it does is contain some data. So, just to make it absolutely clear, what we've just done is we've taken all of the functionality out of the hotspot class and put it into this new player interface class. And the reason we've done that is because we were calling the same function lots and lots of times every frame. And that's hugely wasteful. So we've just put it all in the same spot, and we're not going to have any problems anymore. But we do have an extra bracket. Let's see whether or not we have any errors. Use of unassigned. Oh. Gotta initialize it. There we are. So that looks like it might work. Let's give it a shot. Yeah. Okay, so you see how we do have an error there? It says object reference not set to an instance of an object. On dhighlight.invoke. Of course. So here's one of the fun things. We've set the value, but we've set it to null. So what we actually have to do is say if we're okay. So let me go ahead and show you what the problem is. And these are the sorts of things you're going to run into a lot. Dehighlighting doesn't work. Why is that? Well, if you take a look at the logic of your code, and there's nothing, you shouldn't be scared of this, what we're doing is we're setting the highlighted equal to the new hotspot hit, and then we're calling dehighlight. The problem with that is that hotspot hit is null. So we are using highlighted to keep track of what's highlighted, but we're overriding it with a null value before we actually do anything with it. So what we actually need to do is dehighlight the instant that we know that we've got something new highlighted. So if highlighted does not equal null, highlight the dehighlighted. So the logic here is if we're not looking at the same hotspot we were looking at before, dehighlight the old hotspot, and then highlight the new hotspot. Not very difficult. But this is a situation where if you're refactoring, you can easily get lost in the logic that you had it. You're trying to reuse code, you're trying to move fast, and you end up with these logic errors. Still, even though you can get caught up, and this is my first take, it is very easy to figure out what went wrong, fix it, and make everything work. So now, no matter how many of these objects we put into the game world, we're only going to be calling update once. In fact, we could, if we wanted to save a lot of time, actually delete this. And that would mean that it wouldn't call update at all, and these would be basically free. They would be the same cost as just their mesh without any classes on them at all. So that's a very powerful tool. Now there are a couple of things that we could do instead. For example, instead of having Unity events, we could program in what we want things to what things we want to happen. On highlight might change the material or put a bounding box around it or something. The problem with doing that is that you want to make this as fast and easy for a level designer to use as possible. And the easiest way to do that is to use Unity events, because level designers can go, okay, well, I don't want this boombox here to do the same thing as the other boomboxes. I want this boombox to actually disappear when you click on it. And you can be like, oh, I have to program that in. That's so difficult. Or you could just leave it up to the level designer. There, the level designer now has unlimited freedom to make these things do whatever they want, and the programmer doesn't have to try and keep track of it. The programmer doesn't have to hard code anything. The programmer doesn't have to have a giant switch statement that tries to guess what the developer wants. And even if you are both the level designer and the programmer, you still want this flexibility and this freedom. So the basic takeaway here is Unity events allow a level developer, a level designer, to create levels without continually diving back into the code. Diving back into the code is a great way to A, break your flow, and B, make your code messy as hell. The other thing I wanted to show you was refactoring, and a lot of you are under the impression that I'm a relatively decent programmer, and you saw that even with that very simple refactoring job, I made 2 mistakes. Now, that isn't to say that I would have made those mistakes if I wasn't chattering into the microphone all the time, but you should feel okay about making mistakes, and rather than getting angry, just move through each piece and see where you went wrong. The line numbers come up if there's an error. You can put in debug statements. There's lots of options. But here's the key. The simpler your code is, the fewer bugs you're going to have. That's not true. You'll have just as many bugs, but you'll be able to find them really, really easily. So the simpler your code is, the less work it is to program. This is not very complicated code. Now you might say, oh, you didn't even put any comments in. That's bad practice. Yeah, if I wasn't moving fast, I'd probably put a couple of comments in. But this code is really, really simple. Once you know how the Raycast function works, the rest of the code is basic logic. And even someone who's not experienced with C# can have no problem figuring out what the rest of this code does. So that's it. Try to avoid labyrinthine code. If you find that you're doing something labyrinthine, you're probably doing it wrong. Either break it up into several functions that are very simple, or try to modularize it. Try to decentralize. If you've got code that's doing a lot of stuff, maybe you don't want code. Maybe you want Unity events. Or maybe you want a data table and you're accessing the data table. Or maybe you want it to be something that you set up over here that's like just a variable that you list. For example, I can go over here and change this to max range 30. I don't do a check and see if the name is such and such, set it to 30 or whatever. I just go ahead and have that something I can tweak on the fly. And that means that I can see this guy already. So that's the idea. Try to figure out how you can make your code simpler. Don't worry, don't fear refactoring or decentralizing or centralizing. You've got a lot of time ahead of you. You've got a big project. Even the smallest game is huge. So you might as well approach it without fear. I think that's it. Let me know if you understood this one. This is my very first take, and if it turned out really awful, I might, take it down and do another take. But you'll have to let me know whether you understood it. Thank you. Have a good one.